transmission system has the important role of connecting the prime mover of the revolution, prime mover of the ship to the propeller and passing the propeller thrust to the out. In the simplest case, the direct connect low-speed diesel engine. The transmission is just a straight shaft carrying torque to the propeller's direction of rotation without changing speed of rotation. In other cases, however, the system may be called upon to reverse the propeller's direction of rotation without changing that of the prime mover. Most steam turbines can be reversed, but gasoline engines and gas turbines usually cannot. Uh, some diesel some diesel engines can be reversed, but others cannot. So transmissions you may also contain reduction gears in order to ensure the compatibility of the RPM of the propeller and that of the prime mover. Propellers work most efficiently at relatively low speeds, but seldom over 100 RPM for large ships. But the thing is, most engines can be made smaller if they are allowed to work at higher speed to reduce this conflict. Single reduction gears allow the engine to turn perhaps 4 to 7 times as fast as the propeller. Uh, these single reaction gears are usually used with high-speed diesels, gas turbines, or steam turbines. An altogether different approach to transmissions is via electrical system. The prime mover drives an AC or DC generator, and the derived energy is carried through heavy electrical cables to a driving motor, possibly geared down the speed of rotation. Uh, and this driving motor drives the propeller, turns the propeller. Electrical systems usually lose about 8 to 15% of the energy while being transmitted, and are therefore not as popular as mechanical systems. Mechanical systems, yeah, only lose a few percent during the transmission. However, electrical systems have an advantage of greater versatility in layout and good maneuverability and may eliminate the need for a shock tunnel, and they provide good shock absorbing properties that protect the gearing and main engine from damage. It is usually important in icebreakers. So this figure illustrates the alternative combinations. There are many, as you know, combinations of propulsor, transmission system, and propeller. So one of these was mentioned before. Is combined diesel and gas turbine for Kodak. But there are also other combinations like combination of diesel engine and gas turbine um, and others. Um, okay. In selecting a propulsion system, a designer must balance out a good many influential or conflicting factors, as mentioned before. The table lists representative values for four of the most important characteristics, uh, important considerations. They are uh, required investment over the first cost, overall weight, overall length, and fuel rate. These factors are by no means the only factors that should be considered when selecting components for a propulsion system. Marine engineers must also weigh the relative values of reliability, economic life, freedom from likelihood of explosion, always to select engines, and crew numbers and skills, fuel costs, fuel availability, fuel treatment requirements. They must also think about maintenance and repair requirements, availability of replacement parts, ease of access, ease of control, ease of reversing, uh, and other matters of maneuverability, reversing power, and adaptability to specific hull configurations. Finally, the list includes with lubricating oil means the ability to operate at fractional hours without stalling, shock resistance, relative freedom from vibration, noise, heat, odors, and threat of air and water pollution. Not to be forgotten is the practical matter of engine output powers that may be commercially available. So, of course, there are certain exceptions to these numbers, but the most readily acquired units are usually found within the power ranges indicated. So they are indicated horsepower ranges. You can see gasoline engines, high-speed diesels, medium-speed diesels, low-speed diesels, gas turbines, and so forth. As a practical illustration, this figure shows the arrangement of the main machinery uh, in an oceanographic research ship. This particular vessel uses three high-speed diesel engines to supply electric energy to two drive motors uh, that are connected to a single propeller shaft. That's another image. Uh, then, about the generating the electricity. Over the years, we have seen an ever-increasing need for electrical energy on shipboard. The introduction of auxiliary maneuvering devices such as bow or stern thrusters, special cargo handling, and for cargo access gear are prime examples. Moreover, experience shows that during the useful life of a ship, owners tend to add devices that will add extra demands on the generators. This can range from a little refrigerator in some room to the addition of an air conditioning system for the entire accommodation space. Electrical needs are divided into two parts: engine room and ship service requirements. Engine room is needed to drive the many motors for pumps associated with the main and auxiliary machinery, while the ship's service category includes all the power requirements to make the accommodations habitable. Uh, a ship of any size will carry at least two independent generating units for normal use. They will be so sized that either can be closed, shut down, or repairs without significantly affecting impairing operations of the ship. In addition, most regulatory agencies require that uh, there is require the presence of an emergency diesel generator that must be located above the freeboard deck, outside the engine room, or its overhead casement. Now about the fuels. Uh, Mechanically propelled ships or boats may obtain their energy from a variety of sources like petroleum products, crude oil, coal, nuclear fission, gas, wood or wood chips, etc. Uh, since the great majority of today's vessels, large or small, work with petroleum products, our focus will be confined to this. So petroleum fuel is most usefully categorized according to the type of the engines that these fuels are used. This includes principally gasoline engines, gas turbines, high speed, medium-speed, low-speed diesels, and boilers. Uh, Also, they're also categorized according to their important physical properties, like heating value. Heating value is the property that recognizes the amount of heat energy available in each unit of the fuel. The units are British thermal units per pound or kilojoule per pound. There is also ignition delay. This is a property that is related to the ignition important characteristic called ignition period in this ship engine. This ignition delay is critical in high-speed diesel engine. And then there is density. This is measured in American Petroleum Institute degrees, and it indicates the ease of separating out any water that may have found its way into the fuel. Uh, this process is carried out more efficiently with low-speed fuels because high-density fuels have a specific gravity that is close to the water, to that of the water, so it becomes harder to separate. Then fluidity. One thing related to fluidity is called pour point. Pour point is strictly temperature at which the fuel's viscosity becomes low enough to permit the material to be poured. The thing is, many marine fuels must be heated before pumping, so fluidity and then there are other categories, important properties like safety and cleanliness. Yeah, this is a table from Wikipedia around fuels, fuel oil, the usual fuel oil. Mm, yeah, and grades of diesel oil. So there are different grades. Um, like number one is low viscosity for frequent and is used for frequent speed and load changes. Number two, standard diesel fuel used in cars and trucks. And number four, fuel for low and medium speed diesel engines. The marine industry is plagued with a plethora of semantical confusions with respect to the designations of various kinds of petroleum fuels. What one operator may call marine diesel medium, another operator can call gas oil. So it is really important, it is advised to define terms from the start of conversation. Um, these are some questions that should be answered before for should be answered operating profiles. The questions like how much fuel should be carried in order to complete a given voyage, or the amount of fuel needed during each segment of the voyage, or whether to take bunkers of fuel, each end of a round trip voyage, or only one. Also, the ship operator must add an appreciable margin for contingency for safety. This is an engine control room.